Howdy, folks. So I recently came across this APC back UPS ES750 again in the trash. It didn't have a battery with it, and it had a piece of masking tape on it saying that it was broken and didn't work with any batteries. So I thought I would take it home and see if I could fix it. So long story short, I tested it, and there's actually nothing wrong with it. So obviously, whoever tested this just didn't know what they were doing. So hey, score free UPS. So anyway, of course, I wanted to open it just to see if there was anything wrong with it, maybe inside that I couldn't find through my testing, and also just out of curiosity before I put something like this into service. I don't know its history. I want to know what's inside, what condition it's in. And sorry that this doesn't fit in the frame of my camera. My gooseneck is not long enough. I have another thing I can mount my camera on, but I've got to get a tripod adapter because the tripod threading is different. So I'll solve that at some point. But for now, just bear with me here. I've also turned the gain down on my mic, so hopefully it doesn't clip anymore. So I've already opened this because this was kind of annoying to open. They've got all these cables here, and they're just long enough that you can kind of crack the case open, and you got to kind of slide your hand in to undo them. And this thing, of course, does hold a charge for quite a while, so you have to be careful if you open this. So anyway, I thought I would just take a look at what's in here, something to point with. Yeah, this will work. Okay, so I've discharged everything in here now, so it's pretty safe. So of course, we have just a battery compartment here, and it just takes sort of your standard sealed lead acid cell. I just happen to have one of these. This is an old one. I think this is from 2008. So this is a decently old, it's 9-year-old cell now. And it actually works perfectly fine. So it was not in an APC UPS originally, and I think that might be the reason why it's lasted this long. I know a lot of people just they go to this company, Schneider Electric, for all of their stuff. And I've never been a big fan of Schneider Electric. I prefer Cyber Power Systems, or CPS. Their products, in my opinion, they're cheaper, and I think the quality is pretty much the same or better, and the feature set is better. APC, they seem to, it almost looks like they're kind of trying to create their own ecosystem with their own communications protocols and connectors. Like they stopped using Anderson connectors on their UPSs that have external battery packs, and they've got their own proprietary connectors and stuff, and I don't really like that. And there's also the thing that, maybe this is just me, but I think that the APC UPSs kill batteries a lot faster than than other types of UPSs, because they charge them to a much higher voltage. And I mean, they do this probably so that they can get the the highest stated runtime, but also the fact that it kills the batteries. They puff out and they fail faster. And of course, they can either sell more batteries, or most enterprises that I know of, they don't even bother to replace the batteries in these things. They just replace the whole UPS, and of course that's good for business. And I don't really like that. So the fact that battery was in a CPS UPS, and the fact that it's still good 9 years later, I mean, I replaced it out of as a matter of course, but I kept it because there was no reason to get rid of it. So I'll just put it in this one, and we'll see how long it goes for. But anyway, rant aside, so batteries in here. We've got some pretty high gauge cabling here, of course, which goes down to the board. There's 3 fuses. They all look to be in parallel, so 30 amps each. So that would give us 90 amps total. And in no particular order here. Actually, no, that's not a good idea. Let's actually do something in order here. Let's try and get this in shot here. So on the top, nothing super exciting. We've got a little RF can here, which is supposed to be the surge protection for your your cable television or cable modem. So there's probably just some diodes in here, and they just strap that directly to the ground here. Mains comes in, another ferrite, very large ferrite bead here. I suspect this is more to stop the noise from this thing getting out than stopping noise from getting in. Because of course this is a modified sine wave UPS, which basically just means it's a square wave. It's a square pulse up and a square pulse negative. So it's not a sine wave, and of course being square, it has all sorts of high frequency content in it. And so they've got ferrites here, they've got one on the battery terminal. I think it's more to stop conducted emissions out than stuff getting in, but I'm not an E, so I don't really know. That'd be my guess anyway. Button board. These are the connections to the inverter. There's a little circuit breaker here, and just standard brass bus bars for all the connections. Nothing super exciting there. But on the actual board itself, of course, we've got the mains that comes in here. We've got little boots over the terminals, which look nice. We've got some MOVs here. These are decent sized MOVs, which is good to see. I mean, it is a surge protector, so I would expect to see no less than this in here. Common mode choke and filtering, like you'd expect. There's two relays in here. So one of these, I'm not entirely sure why they have two. I suspect one of them is to switch the unit on and off, and the other one is to switch the inverter in and out. I don't know which one is which. And I'm not going to bother to reverse engineer this because I frankly don't care. We have these two parts here. These are current transformers, so these would obviously be for sensing the current either out of the inverter or through the UPS. One of these would be used probably for overload protection, runtime calculation. I'm not entirely sure why they have two. This is just a regular transformer. So this would be for the switching supply that drives all the low voltage circuitry in here. And then they've got, of course, another two transformers over here. The smaller one would be for charging the battery, and the bigger one, of course, is for the primary inverter. And so there's a decent number of sort of power ICs in here. We've got 4 devices here. These are just MOSFETs, IRF 3205 MOSFETs on these blocks here. And these would be our main modified sine output drivers. And then some of the stuff over here would be charging and other associated stuff. I'm not really sure exactly. And one thing that might be interesting to note is the fact that these heat sinks, they don't look like normal heat sinks. In fact, all of them across all of the devices, they're just blocks. They're just solid blocks of aluminum. They're not actually sort of what you'd expect to see as a heatsink, with fins and everything. And of course, the blocks will have greater surface area than, of course, the little tiny cases of the TO220s. But they, why would they not use like a finned heatsink, which has way more surface area? Because a lot of people would sort of think that. And the reason is because they don't actually want to reject the heat from these parts into the environment. That's not actually the goal of these devices. Because, of course, this is a UPS. So when the power fails, the job of this is to supply power for a short period of time until whatever's plugged in can, be shut down or the power comes back on. So the idea is that the amount of power that flows through this inverter is fixed to the capacity of whatever the battery is in here, right? So there's a fixed amount of energy in this. And so they know that whether this thing's running at full load and it runs for a short period of time, or it's at low load and it runs for a long period of time, the energy that goes through it is fixed, which means that the energy dissipated in all these parts is relatively well known. And this thing doesn't have any vents, as you may notice. There's no vents, so there's no way you can get airflow through this. There's no fans, none of that kind of stuff, which means if you had finned heat sinks and you rejected the heat into the airspace inside of here, that wouldn't really do you so much good, because the air would just heat up and convection would not really help you very much. So what they're actually doing is they're relying on the thermal mass of these blocks. because of course any piece of material, it has a specific heat capacity. So it's basically the amount of energy you have to shove into that mass before it raises by a degree Celsius. So by making these solid aluminum, they have a higher thermal mass, which means these devices are just rejecting heat into this block, and the block will slowly rise in temperature. And the block is sized such that by the time these blocks reach the maximum temperature of the devices, the battery is empty. And the system, of course, shuts down at that point. And because it takes 18 hours or something to charge the battery, these things will slowly cool, and everything will slowly conduct out through the plastics, etc., etc. And the thing will be cool by the time it's ready to go again. So this is one of the big reasons why you can't just connect like a big deep cycle battery to these things and say, oh, hey, this is a 450 watt inverter, I can just run it forever. You can't do that because they are not designed to be run long term. They don't have the cooling for it. Now you can retrofit these. I mean, I've seen people do that where they beef the cooling, they cut holes, they put fans, they put proper heat sinks and all this other stuff. And you can make an inverter out of this. And generally these things are okay with running, forever as long as they have adequate cooling. But you can't just use these as a regular inverter. So that's I guess an interesting thing to note. Seems that the main controller for this thing is actually down in this corner here. It's pretty obvious to tell. It's got a revision 13 sticker on it. It says copyright 2008 APC. This is some sort of STM part. Pretty much all of the chips are made by ST in this thing. So I think they must have some sort of contract with ST, or I'm not quite sure. But everything is ST in this. That's running at 24 megahertz, by the way. So it's probably just a little, maybe a 32-bit processor. But it's being 2008, I'd say it's probably not. It's probably a 16 or even an 8-bit part. Beeper here. The caps in this seem to be pretty much all over the place. So it pretty much looks to me like they just bought whoever sold the cheapest cap that week for that size. So we've got like OST brand, no idea who they are. Palm brand, no idea who they are. Jamicon, so at least I know them. It's all over the place. So 8JH brand, not super great. I really should keep that battery away. That would be bad. If you ever have a lead-acid battery with exposed terminals, do not have metal things near it. You will regret it. So that's safely away. I won't touch it. But yeah, there's not really much to see in this. I just wanted to make sure that nothing was obviously broken or burned or anything like that. But it looks perfectly fine. So yeah, that's wasn't super exciting, but whatever. I'll put it up anyway. So that's what's inside one of these 400. This is a 450 watt 750 VA back UPS. So yeah, I'll put a new battery in, and it'll live till either something in this thing blows up or the battery fails, and I have to figure out whether it's worth it to buy another battery. Anyway, need to stop rambling. As always, thanks for watching.